Well, at least the video should have been playing. So I don't know that it is. So in case the video is not playing, welcome everyone. The SP Technical Section for Well Integrity is pleased to present this webinar on risk assessment methodologies titled Swifra for Structured What-If Risk Assessment. My name is Pierre-Edouard Vincent, and I will be your host today. The event has been scheduled for 60 minutes, but will not have a hard stop. We encourage you to ask questions throughout. For this, simply create comments from the platform you are using. And before we start, I would like to make a few announcements for events related to well integrity, either recent or upcoming. The SP Thermal Well Integrity and Production Symposium just happened in Banff in Alberta, Canada. And I understand it was a great success with record-breaking crowds. So well done to the committee there. And we'll have a casing deformation work group coming up this week in Oklahoma City. I can share more information with this later. And then Georgi has shared a few links on BCSP events and the BCSP Shift peer-reviewed online journal. I will share those links in the chat box. And then there's a Connect 2026 AIHA Premier Occupational Hygiene Conference. With that said, it's now my pleasure to introduce the main speaker for today's webinar, Georgi Popov. Georgi is a professor in the Occupational Risk and Safety Sciences Department at the University of Central Missouri. He's co-author of Assessing and Managing Risk, an ERM Perspective, Risk Management Tools for Safety Professionals, and Risk Assessment, a Practical Guide to Assessing Operational Risks. Georgi holds a PhD from the National Scientific Board, an MS in Nuclear Physics from Defense University in Bulgaria, and a postgrad certification in Environmental Air Quality. He graduated from the U.S. Army Command and General Staff College in Fort Leavenworth, Kansas. He has received multiple awards, including recently in 2025, the Board of Certified Safety Professionals, BCSP, SMP Award of Excellence, and the AIHA Technical Award, and finally the ASSP Standards Medal. Finally, Georgi has served as BCSP Shift Editor-in-Chief since 2022. So before I hand the stage to Georgi, I'd like to welcome to stage Kristen Mong with VAR Energy, who's a colleague I regularly meet at the Well Integrity Specialist Network in Norway also, and Raphaël Waxin, who is a former colleague, and he's seen quite a few risk assessments during his career in various shapes or forms. So we'll be very happy to have you as panelists later in the discussion. And Georgi, I'll hand over the floor to you now and add your presentation to the stage. Please take it away.
Thank you. I really appreciate the invitation, and I wanted to share that presentation with you on risk assessment methodologies, and we're going to introduce a modified what-if methodology. So let me make sure I have adjusted my screen. Do you see the whole screen now?
Yes. We do see the whole screen. It's all good, Georgi.
Oh, okay, I really appreciate that. So thank you for the nice introduction and such a great idea to have webinars like this one. Back in 2000, we published a this very interesting modified methodology called Swifra. So the link was provided in the first slide. And with this methodology, we wanted to make sure we reduce the fatalities and serious incidents, or FSIs. Some of you may be familiar with the other abbreviation that we use, SIF, which is different wording, but in system safety, SIF means something different. So we're not going to expand into that category. So for the purposes of this presentation, we're going to use FSI for fatalities and serious incidents. So with this methodology, we wanted to demonstrate how we can prevent incidents from occurring by asking what if questions. But to ask the what if questions, they should be asked before the incidents occur. And that could be during the planning stage, during the early design stage, the development, installation, the operations, and maintenance of the systems. So we're going to discuss one very interesting chemical safety board case study from a couple of years ago. And currently I'm in Warrensburg at the University of Central Missouri, and where that release, toxic chlorine release, happened is not that far from here, probably 160 kilometers from here to be on the safe side. And we have used the what if analysis assessment tool to demonstrate how that could have been prevented if we were to ask the what if questions early in the design phase. So basically what happened is the operator mixed two incompatible chemicals, and that is the sulfuric acid and sodium hypochlorite. So for all of you in the oil and gas industry, you may be mixing different chemicals, but sometimes they're incompatible. And if you mix these two chemicals, the sulfuric acid and the sodium hypochlorite, then the mixture will produce chlorine gas. And we'll talk about chlorine gas in a moment. But what if the chlorine cloud, impacted the workers on site and the public in the surrounding community? So such questions should be asked early, before incidents and accidents happen. So to begin with, we're going to look at the traditional what-if methodologies. So it was originally developed by the British chemical industry in the 1960s, and they wanted to create an easier alternative to HAZOP. And what-if methods have become a really common process hazard analysis method. But you will notice the traditional what-if analysis example here does not include the risk component. So it's simple what-if question, the causes, the consequences, whether we have control mechanisms or not, and if they're sufficient, and the recommendations. Sure enough, there are plenty of benefits. So this methodology is easier or easy to use. It could be used by employees, supervisors, and then sure enough, we have some limitations as well. So it is only useful if the right questions are asked. And it also relies on the intuition and the experience of the team members. So we need very experienced risk reduction team members. And sometimes you will notice it's subjective and it creates potential for bias. So, what is considered higher risk for one safety professional or upper level manager or financial expert, could be considered different level of risk for more experienced safety professionals. And sometimes it's difficult to translate the results into convincing arguments. So the success of the implementation of what if technique depends on the experience and knowledge of the facilitator and the team. Having said that, there is quite a bit of confusion in our profession because sometimes we use and mix hazards and risks, and we use these two terms interchangeably, and they're not the same. So the traditional what-if analysis methodology that I shared with you just a couple of moments ago is just that. It's hazard analysis. We identify the hazards and the controls, and we analyze the range of severity. But if we add the likelihood of occurrence, notice that I use likelihood, not probability here, because probability is a mathematical term, and we have to be very careful how we use that. So if we add the uh, severity of the consequences and the likelihood, we can estimate that level of risk. And if we evaluate that risk level against the risk criteria that we set early, then we can determine whether that risk is acceptable or not. Here's another very interesting bow tie methodology that you're all familiar with, but very often we use risk mitigation as a term, and we mix them quite a bit. So I have seen, and you're all familiar with the bow tie. You start with the hazard, the causes, and then you have the top event. But before we get to that undesirable top event in our profession, we need to put preventive controls in place so we can add the layers of controls. Then, if that event occurs, in this case, the chlorine gas release, we have to look at the mitigative controls. So, very often I have seen mitigative controls on both sides. So, we want to prevent that top event from occurring before we implement the mitigative control and the resulting consequences. But technically speaking, that is a topic for another great webinar. So, speaking of hazard analysis versus risk assessment and the use of the what if tools, so here you will notice by coupling the what if methodology with an estimation, notice again we're going to estimate that risk level. Very often you will see that in some textbooks we're going to calculate risk level. Well, if you do that, we have to be very careful to make sure it's not subjective and it's real calculation.
Can I
So,
jump in? Can I jump in real quick, Georgi,
absolutely, yes, thank
and
you.
and ask you to take, because Herbert Lescan asked, made a comment, because we can still see your, the share on StreamYard. Do you mind hitting hide, because it's in the way, of some of your illustrations, the presentation. Can you see it?
Um, Let me
Just
see.
hit the
Hit hide.
hide. Yeah, just hit hide. That should be fine.
Let me see.
Can you see
I
that
probably
banner?
have to exit the.
Well, then keep it. Don't exit it. It's okay then. It's fine.
I mean, I can move to the side.
No, it's okay. It's okay. We'll live with it. Don't worry. Thank you.
Okay. Well, I apologize for that. So again, when we couple the what if methodology with estimation of risk, then we can develop a little bit more nuanced version of the what if analysis tool. So here you will notice we ask the what if question, then we have the answer, then we decide whether that's human error or we have system issues, and then we have the likelihood, severity, and then we estimate the risk level and find out whether that risk is acceptable or not. So when we started brainstorming and developing that Swifra process, we put together the sequence of events. So first you have to define the purpose and the scope of that risk assessment. Then we have to assemble a team, and let's make sure we have a very experienced team. Then we have to communicate the objectives. We gather some information, and based on that we generate the what if questions. Then we answer the what if questions. Then we assess the risk, and if necessary, we have to select additional control methods, and then we can communicate the results and we document the findings. So to demonstrate some of the benefits of that tool, I included the link to the video that's available from the Chemical Safety Board. But basically, by connecting the two...
An unintended chemical reaction resulted in a dense cloud containing toxic chlorine gas and other chemicals that drifted into the community.
So basically, by connecting the two connections and mixing the two chemicals that are incompatible, and you will see, how close they were. And when you mix them, here it is. Here's the result. It produced chlorine gas, and chlorine gas is a very it's an awful compound. When you look at the hazard or the risk source, that could be considered the chemical, and it's very commonly used in manufacturing in the United States. But you can see the consequences here. We may have multiple hospitalizations, and in some cases, worst case scenario, it could be a fatal outcome. So to demonstrate the whole process, we built that risk pathway model. So we start with the risk source or the hazard. It's the chemicals in this case. The risk driver is communication or miscommunication in this case. The exposure is who is going to be exposed, the operators, the local population, and the trigger event is the mixed connection. And then the incident is the chlorine release. And as we all know, chlorine was one of the first chemical warfare agents ever used in the battlefield during World War I. And the consequences that could lead to hospitalization, lung damage, property damage. Environmental protection agents in the United States, they can find companies. In this case, it exceeded $2 million, and not to mention the reputation of the company. So to visualize the whole risk pathway model, here is how that may look like. And like I mentioned earlier, the incident is the chlorine release. Now, in order to assess the risk, we have many different methods and options. In ISO 31010, there are, I think, 42 different methods. In the United States, we published a technical report in which we expanded the different risk assessment and risk management methodologies. So sometimes you will recognize a lot of these methodologies, but we're going to concentrate on the what if risk assessment here. So in this case study, we have to decide whether that's human error and whether we have precursors for human error. Basically, the operator of the facility will point to the right connection when the truck driver arrives, and then he will basically hook up the right hose to the right connection, and then there'll be no mixing. But in this case, because both connections were so close to each other and both were identical, they were thinking that the operator was under the impression that he pointed to the right connection, and then he left. The driver, experienced or not, we can argue about that, connected the hose to what he was thinking was the right connection, and then when he realized that he's mixing the two incompatible chemicals, it was too late to stop the process. So we can ask many why questions. Was it task complexity? Was it communication, miscommunication? Was it experience, motivation? But at the end of the day, here is how they looked like. So you will see both of them are very close to each other. Both of them look the same. And just like you have 50-50 chance connecting the right one. We can use the checklist example. So you can see we're going through multiple risk assessment methods. And checklists are great, but if they're not designed for that specific purpose, as you can see here at this example, there is no mention of mixing the connections. So they were more concerned about slippery surfaces, overhead obstructions, different objects, and whether they had easy access to the connections. And if you answer that, if you use just the checklist analysis, maybe we're missing quite a bit. We can use the job hazard analysis. So notice that, again, you don't see any of the risk estimates here. And in this job hazard identification example, we have the task, the risk source, the current controls, and we added worst credible consequences and worst case scenario. So some organizations do two types of risk assessments with worst credible consequences and worst case scenario. And these are the answers. So, here's the task. We're going to transfer chemicals. The risk source is the chemicals. Current controls, we have hazard communication and training. In worst case scenario, in the mixed connection, we have chlorine release and multiple fatalities. In the worst credible consequences, we'll have chlorine exposure, but multiple hospitalizations, like 146 in this case. Now, if we add the risk components to the job hazard analysis, now we can transfer that to a job risk assessment form. We can add the likelihood of occurrence, severity, and the risk level. And if we had done that correctly before that event had occurred, we would have estimated that risk level as high risk and not an acceptable risk level. So sometimes we have to combine risk assessment methods. So using job hazard analysis for risk identification is great. If we expand that to job risk assessment, we're going to analyze that risk, and we can even do risk evaluation. And that's what we'll do with the what if risk assessment and management tool. So we have to expand it a little bit. We start with what if questions. So what if the operators mixed connections? Then we have to answer that. What if the operator is exposed to chlorine gas like he was? I would encourage you to watch that video. And what if the local population is exposed to chlorine gas? Now, in the oil and gas industry, you can consider hydrogen sulfide. You can build exactly the same scenario with hydrogen sulfide. And these are the answers. So, what if the operator mixes the connections? We have chlorine gas generation, and was it human error? It was, but miscommunication, experience. So what if the operator is exposed to chlorine gas? Well, that's possible fatality. And if the local population is exposed, like in this case, they had multiple facilities in that area, even hospitals and other facilities, you may have possibly multiple fatalities. So by adding the likelihood and severity and risk levels, we can do the what if qualitative risk assessment. And you will see that first part is the risk identification part. By adding the likelihood and severity, we can produce that risk level. And that's the risk analysis part. And by comparing that risk level to what's acceptable and what's not, we're going to decide whether that's acceptable or not. And that's the risk evaluation part. Here's how that may look like as far as completed what if qualitative risk assessment tool. And you will see that the first two are very high risk categories. The third one, local population, is considered catastrophic severity, but unlikely because of the distance the chlorine will travel to the local community. And sure enough, if we're experienced, we can answer that risk level is unacceptable. So notice how close these connections were and how they're built exactly the same. And sure enough, that company responded quickly. They redesigned the sodium hypochlorite and sulfuric acid fill lines that way, so you cannot fit that hose to the wrong connection now. In the past, they were exactly the same. They were close to each other. So 18 inches, you can consider that to be 50 centimeters, something like that. Not very far from each other. And then they added more layers of protection, different locks. So now that is not easily accessible, even though they redesigned the connections, just like you can't put diesel in your gasoline-powered, gas-powered vehicle when you go to the gas station or petrol station, for however you want to call that. Again, they added more layers of protection. You can see the updated report. And then you can see we add more risk treatments. Here's another term that we have to be aware of. In the past, we have used the term control measures and hierarchy of controls. As you very well know, ISO 31000, the risk management standard series, describes that as risk treatment. And that's what upper level managers understand. That's what they use. And that's why it is better for us to use risk treatment. And when we get to some of the options, I will explain a little bit more why we have to call that risk treatment strategy. So in this case, we can simplify the operation. We'll design different connections. We'll put engineering controls there. We'll put warning, administrative controls, and easily accessible personal protective equipment, because it wasn't obviously easily accessible. So if we expand that what if risk assessment with risk treatment, now we're going into the risk management category of the risk management process. So we add additional controls. You will notice that in this case, we're using numbers for likelihood and severity instead of the qualitative risk analysis. So we'll do that quantitative risk assessment. And sure enough, we'll produce the same risk level as far as color coding. Based on my experience, upper level managers, they like color coding, and that's why when we share that Excel spreadsheet and the interactive tool, you will see everything is color coded. Then we add the additional controls, and eventually we're going to reduce that risk level. And if we use numbers here, you will notice that we can kind of estimate percent risk reduction. So if we do a little bit more brainstorming session, is that sufficient? Do we need additional layers of controls? Is it too complicated? Is it too simple? Is there any possibility of a human error? So we want to engineer out the even the slight possibility of mixing the connections. So we can go to human error and precursors analysis, and then we'll decide whether that's sufficient or not. And maybe we have to add additional layers of controls. And that's why Bruce Lyon, who was initially started his studies as art major, and now, he transitioned a long time ago in college, luckily, to the safety profession. But we like to visualize things with him, and we built that ALARP visualization as slow as reasonably practicable. And we'll start with risk avoidance or elimination. If that's not possible, we'll try to substitute. If that's not possible, we'll try to minimize, and you will see either quantities or the weight of the objects, or you name it. If that doesn't work, we'll try to simplify the process. Then we'll have passive engineering controls, active engineering controls, and if that's not possible, we'll go to warning and awareness, and then procedures and training, and finally, personal protective equipment. So for most of you who are in the oil and gas industry, you very well know that the personal protective equipment is not even considered a layer of control in some instances. So if we substitute with a sodium hypochlorite powder form, like you see here, we're not going to deliver that liquid sodium hypochlorite anymore. And if we enclose the process, we'll see that we have to re-engineer the whole process to accommodate that powder sodium hypochlorite. But then we're going to run water through it, and then we'll produce liquid sodium hypochlorite. We have to very carefully work with the concentration, but then if we ventilate that area and if we install pollution prevention devices, basically we're not going to have the need to the driver to deliver liquid sodium hypochlorite. That way we're completely avoiding mixing the connections. So that brings us to our next topic of discussion, and that's the hierarchy of risk treatment, or the risk reduction options. Now, you will see early in the design and redesign phase where we can use avoidance and elimination. So the reason we call that hierarchy of risk treatment is because if we avoid the risk, there is nothing to control. If we eliminate the risk, there is nothing to control. Therefore, you cannot call it hierarchy of controls. So using risk treatment, hierarchy of risk treatment, is more appropriate in this case. And then you will see we'll go through substitution, minimization, simplification, passive and active engineering controls, warning, administrative, and PPE. So again, if we add the additional controls, if we substitute liquid sodium hypochlorite with the powder form, and we can automate the process and we re-engineer the system, eventually you will see significant risk reduction. So notice how we have used with just engineering controls and warning and procedures, we're still in the serious risk category for failing in connecting the wrong connections and the operator being exposed to chlorine gas. By substituting, you will see that we were able to reduce the likelihood to as low as reasonably practicable. We were able to reduce the severity of the outcome as well, and now you see 88% risk reduction. That is a very good estimate. Another important thing to consider when you do risk assessments is the cost, and that's why we have to do a little bit of, and you very well know it's in most of our safety engineering textbooks, the engineering cost analysis or cost benefit analysis. So we have to look at the direct costs, the losses in dollars or euro amount or any other currency, the manpower, the replacement, the time it took to recover. Then you have the indirect cost where the downtime, we have to consider that, the customer dissatisfaction, because at that time the customers were waiting on that product and they didn't get it. We have business interruption, we have retention, disposal, and waste, and wasting time on accident investigation. So very often you will hear, I don't have time to do risk assessment. Well, do you have time to do accident investigation? So maybe it's better to ask the what if questions early rather than do accident investigation. Then the benefits, you will see we have reduced workers' compensation. That's at least what we have here in the United States. In Europe, that's done a little bit in a different way. We have reduced property insurance, reduced training requirements, preventive maintenance, and you name it. At the end of the day, U.S. Environmental Protection Agency cited both companies, the delivery and the operator, $1 million each. And that is a lot of money. So imagine how many layers of controls could have been in place if the organizations invested $2 million in safety. To give you an idea how that looks like, here's the status quo on the right-hand side. That is doing business, cost of doing business, just like we did it. But when you spread out that $1 million through the 20 years period, you will see that we're losing money every year. Versus if we had implemented that substitution option, there'll be no chlorine release, and you will notice it wasn't that expensive to convert to the solid sodium hypochlorite. And $89,000 is peanuts comparing to the $2 million. So every year we'll be saving money instead of basically losing $1 million the first year and then $111,000 every year after that. So in conclusion, we promised 40 minutes. 40 minutes it is. With proactive risk assessment and the management process, the organizations can reduce the uncertainty. So notice that uncertainty is another term that we use very often in risk assessment. We can reduce uncertainty and the potential for serious incidents. And methods like the traditional what-if analysis or Swifra can be very powerful tools when we start identifying risks, when we assess the risk, and when we communicate the risk within an organization and with our partners. And as safety professionals, we should be aware that tools like this exist, and the time to ask what if questions is now. So here's our contact information. If you have any questions, we'll be happy to answer. And again, thank you for the invitation. It's a great idea to have such webinars and share best practices.
I have a question for you.
Absolutely.
Yeah, the first one I have is, how did you show how you calculated your risk reduction, the percent risk reduction?
Absolutely. And, we're going to share that tool somehow. It's an Excel-based tool, but that's how it looks like. If you click on that link, it will take you to the video and the whole report. But we have qualitative risk assessment tool. So, when you scroll down, here is the 4x5 matrix that we use. I believe you're using very similar one.
Yeah, that was actually also one of my questions. How did you make this risk matrix, or how do we decide? Because we can kind of mask our risks with which risk matrix we use, and I see that the operators don't use the same matrix.
Aha! So here's the key.
Yes.
Interesting question. Do we use the same risk matrix for the whole organization? And very often, some organizations calibrated their risk assessment very carefully. So they use the same risk matrix for financial losses. They use the same risk matrix for operations. They use the same risk matrix for safety. And, if you were to assign numbers here, so for catastrophic losses, for oil and gas companies, that could be billions of dollars. That's catastrophic. For some smaller companies, that could be hundreds of thousands of dollars, not billions. And you will see this matrix is kind of flexible enough. We have qualitative risk assessment and semi-quantitative, so we have the numbers. So here we can use the possible or catastrophic, so we'll select from the drop-down menu for likelihood and severity, and then we have to select, obviously, that's a high risk. I will go back to the main menu, and here, if we apply the numerical ratings for likelihood and severity, you will see it's the same matrix. Then we can do, and again, I would encourage you to avoid using calculate risk reduction, because that's an estimate, in best case scenario. So, basically, if you say you have 50-50 chance of connecting that hose to the wrong connection, and here it is possible. So if it's 50-50 chance, is it possible that you can mix them? Absolutely. So we'll do something like that for educational purposes. We'll say that's possible, and it's catastrophic outcome because it's chlorine gas, basically chemical warfare agent. So we're going to select from the drop-down menu at 3 for possible. And sure enough, did we reduce the risk from 16 to 12? Yeah, but 12 is still a very high risk category. Is it acceptable? No. And then when we add the additional controls here, as far as engineering, we can say, okay, maybe we reduce the likelihood down to, let's say, unlikely, but that is still considered serious risk. And now you see in this case, it's 33%. If we think that we reduce that likelihood down to virtually possible for that event to happen, yeah, you can say that here, again, it's 67% risk reduction. But again, that's an estimate of the risk reduction. And if we go back
I think
to
sorry,
yeah,
I think the question that was just asked is excellent. I just wanted to mention briefly the fact that in risk assessment, failing to plan is planning to fail. And an aspect in my experience where we are not sufficiently insisting before an exercise, whether it is a what-if exercise or, application of one of the 32 methodologies as per ISO, as you were mentioning, is very important before the risk assessment itself to agree on criteria such as which risk matrix is going to be used, what is the context, what is the scope, who are going to be the participants. I've been in risk assessments, that failed miserably just because of the room, So what is going to be the room? And my main message is to really try as much as possible to put emphasis on this preparation phase to avoid last minute surprises, like realizing at the end of the exercise that the color green for your participants was not the same for participant A and participant B. So really, we could nearly do a what-if failure scenarios for the risk assessment exercise itself.
That is absolutely amazing statement. So unless you do your homework, that's what I call it, the criteria that we're going to use, the level of risk that's acceptable up front, we're not going to produce very good results. So again, that's a great comment. And very often, we wasted weeks of going through the what if scenarios and risk assessment exercises. And at the end, you see, we didn't have good criteria to begin with. And very often our decision makers and upper level managers will tell you, oh, why don't you go back to your office and recalibrate your risk assessment? Because, see, that never happened in 100 years of our existence. So, what makes you think that, it's likely to happen at some point? And, just because somebody from upper level management thinks that, it's virtually impossible because it didn't happen in the past, we have to be very careful with that.
I have also a comment about escalation, because we risk the status we have today and we forget to include the escalation potential for the status we have, because that can add a significant risk, and we have to see if we can tolerate escalation and if we can manage it and detect it. And I have never seen that in a risk assessment tool. So I don't know if you have any comments about that, if it's possible to kind of include that.
So you mentioned something very important, the escalation factors. And I think that is a whole topic for the bow-tie analysis, which I would absolutely encourage you to do another webinar on it, because we can spend a whole semester on going through preventive measures and escalation factors, and even on the mitigation side we can use that escalation factor as well.
So on that, I really like your comment, Kristen. And for us, it's a slightly different way to also frame it. It's the aggregated risk for installations, which is relevant for industrial sites where you have a number of different processes together. And while it's relatively easy to visualize the potential for escalations when the degradations are few, the deviations are few from the original safety case, once you start having multiple deviations, then it's a lot harder to keep track of that escalation potential.
That's also a factor.
Yeah.
And in this same direction, I wanted to ask for which scenario, at what point do you stop in the if sequence? Is there a moment where you consider that by adding more if, the scenario really starts to become very marginal?
And that is another great suggestion, because if you look at that curve where we start applying, we start asking more what if questions, and we start applying more and more and more layers of controls. At some point, they call that in financial management the point of diminishing returns.
Diminishing returns, yeah.
You can apply more and more and more layers of controls and make that even more complicated, but at the end of the day, you don't want to spend $1 million in additional layers of controls where you're going to save, let's say, $50,000 on small paper cuts or slips and trips and things like that.
And so about that, and then I'll show a comment by or a question by Bhaskar Murugapan. What do you guys on the panel think about the time constraint that we have on top of the budget constraints? So safety, absolutely, very critical, absolutely, and we absolutely do not want to harm people and impact the environment. But as Georgi said, you get to a point where you either get to that diminishing returns, or you have to deliver a risk assessment with a small team within an hour, or you have 2 hours. So how can we effectively prioritize this? And do you think?
Yeah, I can speak for the oil industry. When we have barriers for hydrocarbon release, in our company we risk kind of the one extra thing that can go wrong with the consequence of hydrocarbons to surroundings. So we don't kind of, if you ask too many or what if questions that actually doesn't make any difference, you lose focus of your risks or your hazards. I mean, so so we are trying to limit our scenarios. So we are finding scenarios that we risk. Yeah.
On my side, Pierre-Edouard, what you know my thoughts about that. I think our industry is facing a huge trade-off, and I've been involved in my past in well integrity risk assessments, for instance, and our industry is dealing with an aging portfolio. Right now is kind of a period of skinny cows as well. And there is a scarce qualified amount of resource to perform those risk assessments. And this tiny team, this tiny task force, I may say, in general, is facing a vast backlog of wells risk assessments. So I don't have the answer, but there is most likely a compromise to be found between accuracy and efficiency. And this compromise is even mentioned, by thinkers like Eric Olnagel. They call it the ETO, efficiency thoroughness trade-off, to be found by the industry as a whole. Again, I don't have the solution. I've just been observing the reality of this trade-off.
And for you, Georgi, I noted that in your presentation you kind of highlighted, and I think rightfully so, the role of safety professionals. So what do you think is a good group to to perform a risk assessment?
I personally, based on my experience, you need no more than 7 to maximum 10 members of that, and I call that risk reduction team. But we absolutely we're going to invite somebody from upper level management. Whether they'll participate or not, or they'll delegate the responsibility. That's a whole different story. We need engineering because obviously we have to do some modifications. We need financial experts because they have to be involved to understand why we need to spend the money, right? Nothing happens without financial analysts' approval. In some cases, they call them bean counters. Based on my experience, don't ever say that word. They hate it. But who else do we want to involve? Maybe HR, talent acquisition, we call them these days. We absolutely need an operator or somebody who is familiar with the equipment. And did I forget somebody? Absolutely. That's us. We have to lead that team.
Mm.
So,
Yeah, sorry.
Please go ahead.
No, I just we never include the financial part in our company. We don't invite them, and we don't risk the economy. But I know that's different from.
But then you tell them, hey, we need $1.5 million.
Yeah.
And what do they tell you? Do you need that today or tomorrow is fine?
Yeah,
right?
We do.
Yesterday.
And sure enough, do you get it tomorrow?
Well, but we have clear
It's
rules.
not in the budget, right?
If the risk is on that level, that's So,
Georgi, I had one last question for you. You mentioned in the pitfalls of the approach, sometimes the variability between teams. What is your recommendation and advice to increase the level of consistency and to reduce the variability in risk assessments in general?
I have a perfect tool for you. It's called Delphi technique. It's one of the methods mentioned in the ISO 31010. And there you can calibrate the risk assessment for everybody on that team, even between departments, between, different organizations, different sites for your organization. It's an amazing technique. I see one interesting question here in the chat session about the probability risk assessment and the qualitative estimate. And
is that the one you had in mind? The question from Darren? No,
there could be multiples on that, and that's why many times I stated that it's a risk estimate. When you do qualitative or semi-quantitative, it's an estimate. When you have to do probability risk assessment, you use probability calculations. You can use Monte Carlo simulations. You can use many different things. However, even the best probability assessments and calculations are estimates. I have seen pumps and valves that were rated to be failure mode is one failure in 121 years, and then it failed after 6 months. And guess what they tell you? Well, congratulations. That means for the next 120 years, you're not going to have another failure, right?
So I think for us as an industry, we're confronted with relatively few databases for equipment reliability. And my personal experience has been always to very carefully see where the data set was extracted, because there can be a huge variability between regions depending on practices. So there are many other factors explaining potentially equipment failure while in service that would not necessarily appear or be captured in one single data set. And I think it has been a problem for the industry using such data sets more widely. But they shouldn't be. It depends on regions, depending on practices. Results can be quite different, relevant to what you said. Yeah. Georgi, I don't know if you saw that. Any comment on the question? The question asked by Darren Worth on Bayesian networks which I'm absolutely dry. I don't even know what they are. So if you do, you can comment. I think it's about interaction between and connection between events.
I will absolutely encourage you to take a look at the industrial hygiene risk assessment tools. We use Bayesian statistics there quite a bit. And, they're freely available from the American Industrial Hygiene Association. After the webinar, I'll send a link. Maybe we can share that with the participants. But there are amazing tools that we use in the industrial hygiene profession, and maybe you can just modify it to use the same tools for pretty much system safety and any other type of risk assessment.
Very good.
I have another question for you, Georgi.
Yes,
many stakeholders today in the industry talk about gamification. Do you think there are ways to make risk assessments today? So your method is very intuitive, and it gives the initiative, to want to participate. But are there ways to make risk assessments for you even more engaging and maybe even fun?
That is actually a great idea. And I would absolutely encourage you to use the games theory and gamification when you do risk assessment. It's an amazing tool in our toolbox. Sometimes, if you make it too complicated, based on my experience with many safety professionals, when they think it's too complicated, they're not for me. I'm done up to here. But depending on your team and the expertise, you can make it like a fun game of risk assessment. And, that's why, I would encourage you to invite your financial experts to your risk assessment team. You will see they may bring interesting points.
I love your suggestion, Georgi. We should invite them to the game. Maybe not the real risk assessment, but
yes,
maybe start with the game.
And start asking the what if questions, and then all of a sudden they realize, oh, these guys have a good point. If I invest that much here, I'm going to save money in the future. So.
Yeah. Okay, great. Well, we have discussed matrices and how they were not necessarily always the same. There's 4x5, there's 5x5, there's 6x6, there are multiple combinations. Whatever the specific methodology you choose, the rest of the philosophy is pretty much the same. And we haven't had yet the chance of tapping into the experience of Kristen, for instance, but we hope to have you maybe in the future present what happens after that, after the risk assessment, and how we can control the situation, and making sure that the snake stays in the basket, so to speak. We haven't talked much about training today, but we have highlighted, I think, how important the human aspect is in the risk assessment itself, and how we probably have to depend on humans for quite a while, and how potentially going without humans is, I don't know, it's probably not very practical to do that today. We need competent people to do that.
I would be very interested in a webinar
on that.
On that,
yeah.
absolutely.
Well, I'll open the floor. If you, this was a very interesting first webinar on risk assessment, and thank you, Georgi, for presenting the basics of a methodology, which all the panelists today, or the people on the call, were familiar with, applying those principles, generally speaking. But what else do you think would be relevant for a future webinar? Kristen, maybe something you'd like to see?
Yeah, what you mentioned, like follow-up actions from a risk assessment. How do we accept the risks? Do we know what terms we accept the risk? Do we know that action is being followed up, performed? Can we have open actions? Can we have repetitive actions? How do we follow up that one? So, and can we have that, and also follow up of the risk assessments, like do the risk change over time? Should we have kind of a time limit frame, and then we have to do it again?
Do
the risk again, and the level of
Rafael?
First of all, thank you. I think this session was super inspiring, and I really want to thank you all, and also thank the audience. I was very interested by the zoom you made on the alert demonstration, and I think this is a step that some part of the industry is not mastering well. In risk assessment protocols, we usually mention this step of cost-benefit analysis, and we don't always really do it. And there is really a lot of questions around how to perform a good cost-benefit analysis. So I think it could be really the topic of one webinar. Then the question was asked about Bayesian networks. I'm sure we could have a discussion, a very rich discussion about prediction, and what is allowed by Bayes' theorem today. I'm a very big fan of the approach, provided some precautions, of course. And then I know around the table some big fans are here about gamification. So I'm sure we could launch a debate with plenty of very rich and inspiring ideas about making our operations and making our risk assessments a game.
Well, very good. Georgi?
I just shared a very interesting business case tool. Take a look at it. It has two different risk matrices, but the numbers are more important. How we can use that. Perhaps you can share that with our audience.
I will just now. Very good. And yeah, about the future sessions, absolutely. So I would love to have that layer protection analysis card game just to familiarize people about the methodology. And I just thought that it would be having it as a game with a time limit would make you feel a little bit of that real pressure, because we can't spend 6 hours doing a risk assessment most often. We don't get access to our operations people for that long. They have to be busy, you know, looking
Producing.
at exactly, producing. You're looking at addressing alarms, keeping installation safe. So we unfortunately have to work, with some very real constraints. Now the ALAR concept, Rafael, absolutely. I think it's going to be a tricky discussion. It is a tricky discussion, because you'll have a tension between regulations that allow no failure, and sometimes even worse than that. You have to think, okay, what is acceptable in terms of human consequences? How much can you tolerate? Tell that to somebody who's been injured. It's a difficult conversation, but it has to be real. So look forward to that. Very good. Well, if we're at the end of our event, then I will thank you all again, Georgi, Christine, Raphael, for being with us today. And please follow us on SP Connect and the LinkedIn page, and keep it in tune. For the next upcoming event. Thank you. Have a great day.
Thank you.
Thank you.
Bye-bye.
People ask me why they should join SPE, and what I tell them is that SPE is absolutely essential. Frankly, if SPE didn't exist, somebody would have to go out and create it. When you graduate with a technical degree, a petroleum engineering degree, or other engineering degree, you get a lot of really good knowledge that gets you started on your career, and you learn a lot on the job. But the jobs that we have in this industry, they're really quite difficult. And you've got to have other resources, either to solve specific problems you might be having at the moment, or to better understand how to solve, daily issues that you work on. SPE provides opportunities to learn about new things that people are working on. There are great articles in JPT magazine and the other magazines that we have that are really useful. If you're not reading JPT every month, I tell you it's essential to do that, to keep up with the technology. We have excellent conferences where you can learn from people who have solved very difficult problems in our industry. And doing that is just incredibly important and incredibly useful. To me, I don't see how you can be an engineer working in the petroleum industry and not find value in the resources and the opportunities that SPE provides. It's an opportunity to meet people who can help you in the industry, and it's an opportunity to get the knowledge you need to be successful.